UT won't be difficult. 50, 60. You should improve next time. How much your brother got? Total? 133. We need 200. 200, that is good mark in UTs. 2 chapter only, no, we are asking. So 2 chapter also we are not able to plan and revise properly. No? How we will revise that 25, 30 chapter in each subject. So next time do well. Okay. Go break. Don't see like that. Go maybe 7:15 we'll start. So online students, can you hear me?
Yes, sir.
How was your exam yesterday? You said you can hear me, but like now I cannot hear you. What is your take on yesterday exam? I don't want your mark. Anyway, by tomorrow or day after tomorrow, I'll be knowing your mark. What you felt in the exam? Easier, difficult? I'm talking with you guys. Please do respond.
Easier only.
Easier only,
Maths
va?
easier.
Maths easy only. Okay, good. What I have seen in UT exams is like mostly the UT exams will be on easier side. So like once exam is over, what we should, I think you will be knowing there is something called for error analysis, or like they will say finding out the mistakes and fixing them. We will speak about it today, how to do. So Hariharan, can you hear me?
Yes, sir.
How was your exam yesterday?
I scored 24 only, sir.
Why?
சார் நான் எல்லாத்தையும் அட்டன் பண்ணேனா அது அப்படியே மைனஸ் மார்க்லயே போயிட்டுருச்சு சார்.
So this is what now everybody thinks like that way only. Maybe you should reduce your minus mark thing.
நெக்ஸ்ட் டைம் கரெக்ட் பண்ணிப்பேன் சார் கண்டிப்பா.
What about others? Who is there? Santosh. So maybe remaining guys are not speaking. Then I'll assume they don't want to share with me. Good evening, dear. Hmm. I think this is last class only. You would have solved, I guess, by now. Before starting today's class, you have given one exam yesterday. Maybe you would have got good mark or bad mark, whatever mark it is. What we should do after writing the exam is like maybe after a day or 2 days, you will get your analysis again. I think like you can see your question paper again, and you can see like where you did the mistakes. I say like we need to correct our mistakes and we need to identify phone you are using. Huh? See, like we need to identify where we did incorrect and we need to identify where there is gap. Gap, I mean like which we couldn't solve that one due to because of some gap. So maybe tomorrow or day after tomorrow, Saturdays, I think class won't be there. Saturday or Sunday, one day you plan and like you look back to the same question paper again, refer to it, and then like first you go and then take away which problems you did mistake, and then like why you did the mistake, identify the reasons, and then like please don't repeat those kind of mistakes again for next exam. That is first thing you need to do. And the second thing we should do is like we should check or like we should refer to the problems which we were not able to do in the exam, and then like we should ask ourselves why we were not able to do those problems in the exam. If you have answers for these things, if you found out, then like you did well in this, like you can do better next time. Clear? So like before starting anything new, please do this one, right? And then like we will start then today's class. That's all right. So in today's class, we are going to study about an important matrix that is called as orthogonal matrix. Like, do you guys know anything about the vectors? Like maybe, do you know what is orthogonal vectors means? Mutually perpendicular. When we do the dot product between two mutually perpendicular vectors, what we will get? 0, right? So like in orthogonal matrix, you take any two rows, like row 1 and row 2 will be orthogonal to each other. You do that dot product, you will get 0, right? Column 1 and column 2, any two rows or any two columns will be orthogonal, right? So like first let us understand the definition and see one basic example, and then like we'll see the properties and problems on that. Clear? So this is after symmetric and skew symmetric orthogonal matrix. So like rectangular matrix cannot be orthogonal, so we should take a square matrix if A into A transpose is equals A transpose into A is equals identity matrix. If any matrix satisfying this condition, then that matrix is said to be orthogonal matrix. Let us take one example of orthogonal matrix. Matrix A is equals cos theta, sin theta, minus sin theta and cos theta. So like as I mentioned earlier, in orthogonal matrix, any two rows or any two columns will be perpendicular to each other. Dot product between them is 0. Now you consider here there are two rows, row 1 and row 2, like so like cos theta and minus sin theta you have dot product, and then like sin theta and cos theta. So like both will get cancel. I'm talking like this is I thing and this is j thing. For one vector is I cos theta plus j sin theta. Second vector is minus I sin theta plus j cos theta. If I do dot product between these two vectors, I'm going to get 0 there. In the same way, you can also consider like this one as like I here, this one as j here. Column 1 is I cos theta minus j sin theta, that is one vector. Column 2 is I sin theta plus j cos theta. Do dot product between them. Dot product between any two row vectors or any two column vectors will be always 0. That is the orthogonal matrix, right? In matrices, in another way, what they have defined is A into A transpose should be equals to identity matrix. Now A is given. Let us find A transpose here. If we are finding A transpose, we are going to get this one as cos theta minus sin theta, then sin theta and cos theta we have. Let us multiply them. A into A transpose we will be having is equals cos theta sin theta minus sin theta cos theta, and then like here cos theta minus sin theta sin theta and cos theta. Let us multiply and check whether we are getting identity matrix or not, right? How much is this? So like if I see cos theta into cos theta, that is cos square theta, plus sin theta into sin theta, that is sin square theta. Next, minus cos theta into sin theta, then plus sin theta into cos theta. Clear? Right? So now in the same way we have minus sin theta into cos theta plus cos theta into sin theta. Minus into minus plus sin square theta plus cos square theta. So what is happening here? We have 1, 0, 0 and 1. So we got A into A transpose. That one is equals identity matrix. You will also get A transpose into A is equals identity matrix over there. You guys understood? Copied? So like you have a problems, direct application problems are like a little different of this one. In JEE mains they asked here, right? And then let us see problems involving orthogonal matrices. Can I scroll up? So like now if you have the books, please open page number PYQs of JEE mains. I'll be talking. So like one moment please. Page number 30, problem number 24. Page number 30, problem number 24. Just one application problem we are seeing on orthogonal matrices. Like so like page 30, problem 24. I hope everybody has package with you. See this problem, problem 24. They have given a matrix P, they have given a matrix A, they have given a matrix Q, QS, P into A, P transpose. Then they are asking about the Q here, involving Q, right? So like, what is my claim over here is, the given matrix P is a orthogonal matrix. How did I say that one? How can I say about that one? Like, because P is equals to a root 3 by 2. A root 3 by 2 will be equals to cos theta. Then 1 by 2 is sin theta. Minus 1 by 2 is minus sin theta. Then root 3 by 2 is again cos theta. Clear? So like this matrix over here is orthogonal matrix. A is equals to 1, 1, 0, 1, which is a upper triangular matrix. They have given Q is equals to PA, P transpose, right? Now they are asking like they have given. Let's call this one as P transpose Q power 2007 into P is equals. They have given A, B, C, D here. Now we need to find the value involving A, B, C, D. Right now, quickly, since we can see that P is a orthogonal matrix. If P is a orthogonal matrix, we can write P transpose into P is equals P into P transpose is equals identity matrix, right? Now like I am using the definition of Q, substituting here, like where I am substituting in this P transpose Q to the power 2007 into P will be equals to P transpose PAP transpose whole power 2007 into P, right? So now P transpose, PAP transpose, PAP transpose, and then again PAP transpose, and so on. I have PAP transpose into P I have, right? See, matrix multiplication may not be commutative, but matrix multiplication is associative. Using that, let us write P transpose into P, and then like A into P transpose into P, again A into P transpose into P, A into P transpose into P, dot dot A into P transpose into P. Using associative property of matrix multiplication. P transpose P is identity matrix. Only A you will be having everywhere, right? How many times you have A here? A you have is 2007 times here, right? Now you find A square, you find A cube. You will be having the pattern clearly. If I am not wrong, A power 2007 will be equals to 1, 2007, 0, and then 1, right? So now if this one is equals, like now comparing with the given matrix, A is equals to 1, B is equals to 2007, C is equals to 0, D is equals to 1. Now what we need to find here? We need to find here 2a plus b minus 3c minus 4d. So 2a plus b minus 3c minus 4d, which will be equals to 2 plus 2007 minus 0 minus 4. So we have 2005 as the answer. If you studied about inverse in the school, you can try problem number 47 and problem number 53. Again, these two problems are problems on application of orthogonal matrix and the properties. Clear? Understood? Any doubt in this, anybody? Online, offline, any doubt in this problem? Please do let me know if you are having any doubt in any part of this solution. If you know about inverse of a matrix, you can solve problem number 47, problem number 53 as well. These two are problems based on inverse of a matrix. If we don't know about inverse of a matrix, we cannot solve these problems. Clear? If you didn't study it, is not recommended. I'm scrolling up. Can I? This much I think okay, right? Yes. No, not only 2 into 2. This is for orthogonal matrix. If you take, no, like 3 into 3, I didn't give any example, no? Did I give any example for 3 into 3? Same thing like I, J, K. Row wise you take. Row 1 and row 2 will be perpendicular. If you are smart enough, you will understand A I have. A transpose I have. A row becomes column there. What you do? A row 1, you do dot product with column 1. Same thing. Some constant you will get. Like identity you should get 1 there. And then like next row 1, the moment you are doing dot product with column 2. Right? So technically the column 2 of A transpose is a row 2 of A. Dot product between them, we should get 0. That's what the definition says. Dot product between any two rows or any two columns in a orthogonal matrix should be 0. Right? The row vectors or column vectors are orthogonal to each other in a orthogonal matrix. Clear? That's why only it is orthogonal matrix. Any doubt? Understood? Can I scroll up? Anybody writing this? Copied, right? So maybe few properties of orthogonal matrix, 1 or 2, and then some special type of matrices also we should see here. Right? Give me a moment. See, like property number 1, this is an important property based on definition of orthogonal matrix. In a orthogonal matrix, the dot product between any two row vectors na entire row, any two rows or any two column vectors is 0. That means rows are perpendicular to each other or columns also perpendicular to each other. This is the property of orthogonal matrix. Clear? Understood? Right now, see, like we have taken now one matrix. So there we have considered like A is equals to cos theta minus sine theta and cos theta. If this is the matrix A, right, A of theta, then you are finding A square, A cube, A power, something like that. I can write A power n of this orthogonal matrix will be cos n theta minus sin n theta. Again, this is sin n theta and then cos n theta. So like based on this property, like you can clearly show that it is not difficult. A square you find it. When you do the A square, you will get cos 2 theta minus sin 2 theta. Again sin 2 theta, cos 2 theta we are going to get, which is A of, right, A power n. This will be equals to, like I can also write A power n is equals A of n theta. Not difficult to prove and all. If you want, you find A square. A square of theta will be equals to A of 2 theta. A cube you will get as A of 3 theta and so on. Based on this one, you have like page 32, problem number 45. They have given the matrix A, which is a orthogonal matrix. They have given like then the matrix A to the power minus 50 at theta equals pi by 12. Right? A to the power minus 50 will be equals to A of minus 50. Clear? A of minus 50, then A of minus 50 you use and you will get the answer here. Clear? Please solve that one. It is easier, I guess. So what I get here, I think it is cos of 50 pi by 12, sine of 50 pi by 12, minus sine of 50 pi by 12, cos of 50 pi by 12. How much is 50 pi by 12? It is 25 pi by 6. 25 pi by 6 is, I think, 4 pi plus pi by 6. So 4 pi is same as like 4 pi plus first quadrant. So cos pi by 6, 1 by 2. Root 3 by 2 I need. I think second option is what I have. No. One moment. Cos pi by 6 is root 3 by 2. Third option. No. Third option. So like now, third property as Mithun asked. This is like an example for orthogonal matrix of order 3. Let's say this one you call as A of A is equals cos x minus sin x 0 sin x cos x 0 0 0 1. Right? So this matrix A over here is a orthogonal matrix. We can clearly verify dot product between row 1 and row 2 0. Row 1 and row 3 is 0. Row 3 and row 2 is also 0. If it is happening for all rows and all columns, any one will be sufficient to say it is orthogonal. If this is not good for you, you are not understanding this way. What you do is do transpose, multiply normal way, A into A transpose is equals identity you will get. That is a orthogonal matrix. This orthogonal matrix has a property. We can say A of x into A of y will be equals to A of x plus y. We can show that, not difficult at all. Right? And then like inverse of this, I think inverse you guys didn't study it, no? Now we cannot see that one about inverse. Any doubts? We have seen the basics of orthogonal matrix, right? Then what else you can also solve from this here is problem 22 you can solve, I guess. I think this is orthogonal matrix. Use a power n of theta property to solve this one instead of trying to get pattern. So I don't know, pattern may not be there in problem 22. You can try solving using the property a power n of theta is equals a of n theta. So clearly it is orthogonal matrix. 22nd problem using the second property. Any doubt in this? Orthogonal matrix is this one. Try problem 22. Done. Say something, no? Done, no. Doubt, no. Not able to get the answer there. Problem 22 is what I'm speaking. It is given in the problem A is equals to 1 by 2 root 3 by 2 minus root 3 by 2 plus 1 by 2. So this is in the form of let's say A of theta is equals to cos theta sin theta minus sin theta and then cos theta, where theta is equals to pi by 3, I suppose, right? So now we need to find in all the options they are talking about a power 30 and a power 25. Now using the property for this kind of matrix a power n of theta is equals a of n theta, finding a power 30 of theta. A power 30 of theta we have is cos 30 theta sin 30 theta minus sin 30 into theta cos 30 into theta we have with us. Clear? Now like maybe pi by 3, the moment we substitute, we get a power 30 of pi by 3 will be equals to 3 is like 30 is a multiple of 3, we get cos 10 pi sin 10 pi minus sin 10 pi cos 10 pi. So like sin of n pi value is 0, right? So we got here cos 10 pi value, anybody? Cos 10 pi value is 1. 1, 0, 0 and 1, which is a identity matrix. Now what about a to the power 25 of pi by 3? A to the power 25 of pi by 3 we get cos 25 pi by 3 sin 25 pi by 3 minus sin 25 pi by 3 cos 25 pi by 3. So like what we can write, cos 25 pi by 3 will be equals to, I think like 8 pi plus pi by 3. So first quadrant we are having, we can say this will be equals to cos pi by 3, which is 1 by 2 root 3 by 2 minus root 3 by 2 and 1 by 2 we have. So therefore we can write a to the power 25 is equals to a, then next to this a to the power 30 is equals to identity. Now we need to add them, subtract them. What we should do? So like in one option, they have mentioned it a to the power 30 plus 8. Okay, like second option, for that we are adding a power 30 plus a power 25 is equals to a plus I. Next we can write a power 30 plus a power 25 minus a is equals to identity matrix. That is second option. Understood this one? No? Understood this one? See, like they have given a matrix A is equals to 1 by 2, root 3 by 2, minus root 3 by 2 and 1 by 2. I can see that here A is a orthogonal matrix. So like once I know it is an orthogonal matrix and it is in the form of cos theta, sin theta, minus sin theta and cos theta, right? So like what I did is I used a property, this property over here. If you want, you can multiply and check here. A square, you find a into a, you will get a of 2 theta. A cube, you find, you will get 3 theta and so on. Using that, right, we can write that a power n of theta is a n of theta. So first a power 30 we are finding, a power 30 is like cos 30 into pi by 3, sin 30 into pi by 3 and so on. Right? Now 10 pi values for cos and sin we substituted, we got a power 30 as identity. In the same way a power 25 we are calculating, a power 25 we got same as matrix A. Right? Now using them both, 1 and 2, like a power 30 equals identity, a power 25 equals a. Adding them, I got a power 30 plus a power 25 is equals a plus I. Now I rearranged it. I got a power 30 plus a power 25 minus a is equals identity matrix. Clear? That is answer. Copy this one. Anybody writing this part of this slide? Done? Can I scroll up? Everybody copied this sum. So like then there is something called characteristic polynomial of a square matrix. Like in detail about this characteristic polynomial, we will learn in determinants chapter. But like I think I have seen there is one problem here. I think two problems here which we need to solve using characteristic polynomial. For every square matrix, there will be one characteristic polynomial, right? Or there will be an equation which is derived from characteristic polynomial. You would have seen in your NCRTs if you studied matrices, there they'll give you a square matrix. They'll ask you to prove that a square minus 4 into a and then like plus 3 into identity matrix is equals to null matrix. Anything like this you have seen in NCRT. It can be cubic as well, right? After showing that, maybe they might ask you to find the inverse or something. Clear 5 mark, like that one is actually born from a characteristic polynomial. In this chapter, you just write as a note. I'm giving for second order square matrix, right? So like one small note. In determinants, we'll study in detail. So like in general, this will be the characteristic polynomial for a square matrix of second order. Characteristic polynomial na some polynomial. This is lambda square minus trace of a into lambda plus determinant of a will be 0. Characteristic polynomial will be satisfied by the matrix itself. I can write a square minus trace of a into matrix A plus determinant of A into identity matrix of second order should be equals 0. I can substitute lambda is equals to A and this is what we get. Clear? So like now based on this concept, there are problems in our matrices chapter. If you want to do this one for any matrix, like let us take a simple square matrix, second order one basic example. See like matrix A is equals to 2 minus 1 1 and 1. Mithun, if you are wondering about like why identity matrix came here, their determinant of A into lambda power 0 we will be having. In place of lambda, we are substituting matrix A here. A to the power 0 for a matrix we will write as identity matrix. Clear? Understood? Right? So like if this is the square matrix of second order, I can say the characteristic polynomial or like I can directly write a square minus 3 into a plus determinant will be 2 plus 1. 3 is into identity matrix is equals to 0. If you want, you can check here. Can anybody here calculate and tell me how much is a square here? For the given matrix A square minus 1 into trace of a matrix into A plus 3 into, this is determinant guys. Determinant will be these two product A into D minus B into C. Right? Sorry, A square, somebody telling. A square is 3 minus 3 and 3, 0. Now, if we substitute in the above equation, we have 3 minus 3, 3, 0, minus 3 into 2, minus 1, 1 and then 1, plus 3 times of 1, 0, 0 and 1. So adding everything, what we get? 3 minus 6 plus 3. Minus 3 plus 3. 3 minus 3. And we have like minus 3 plus 3, which is a null matrix. So we got all zeros. Now using this concept, we can solve problem number 23 and problem number 27. Problem number 23 and problem number 27 are problems which we can solve using characteristic polynomial of a square matrix. Clear? Can I scroll up? Everybody copied? See problem number 23 first. So like problem number 23, they have given that P be a square matrix such that P square is equals identity minus P. They only given the characteristic polynomial, no need to create. We can write P square minus P plus identity matrix is equals to 0. Anything we use if we need. Right? And then what they have given for alpha, beta, gamma, and delta belongs to natural numbers, right? What is given? P to the power alpha plus P to the power beta is equals gamma into identity matrix minus 29. Similarly, P to the power alpha minus P to the power beta is equals delta into identity matrix minus 13 into P you have. So like maybe adding them, if we add them, what we get? 2 times of P to the power alpha is equals gamma plus delta into identity matrix. And then like how much is this? Minus 29 minus 13 seems minus 42 into P. So P to the power alpha is equals gamma plus delta divided by 2 into identity matrix minus 21 into P. So like we need to take the minus P over here, like in P square, we have I minus P. So the minus P we should take till minus 21. How can we take like? Let us consider P to the power 4. P to the power 4 will be equals to P square into P square, which is I minus P into I minus P. If we do square, like it is square only, we get I minus 2P plus P square. Now substitute P here, we get how much is this? I minus minus 2P plus I minus P. So we have 2I minus 3P. Understood this one? Understood this one? Oh. So like I think we are using this one. P power 4 I did, like I'm nowhere near, right? Then maybe I'm trying to get P to the power 8. P to the power 8 is P power 4 into P power 4. That is 2I minus 3P whole square. How much is this? We get 4i, I think like this is 2 3s are 6 minus 12 into p and then 9p square. Now substitute p square here. So 4i minus 12 into p plus 9 times I minus p. So like this is 4 plus 9, 13 into I, and then like minus 12 minus 9 is minus 21 into p. So like I understood here, p to the power 8 is equals 13i minus 21 into p. So therefore I can write alpha is equals to 8. Then gamma plus delta by 2 is equals to 13. Gamma plus delta is equals to 26. I think beta alone we need a alpha. Okay, everything we need. Then again, same procedure again. Subtract them. If we subtract these two equations, maybe 2 and 3, if we are subtracting, we get 2 times p to the power beta is equals gamma minus delta into I minus 16 into p. P to the power beta is equals gamma minus delta by 2 into I minus 8p. So 8 we need. So 8 means I think in between p power 4 and then, okay, like let us calculate p to the power 6 here. P power 4 into p square, that is 2i minus 3p into p square is I minus p. 2i minus 2p minus 3p plus 3p square. This is 2i minus 5p plus 3p square. So this is 2i minus 5p plus 3i minus 3p, I think we reached. This is 5i minus 8p, p power 6 again. On comparing we get beta is equals to 6. Then gamma minus delta is equals to 10. So how much we get now adding them? 2 gamma will be equals to 36, gamma is 18. If gamma is 18, then delta will be equals to 8. So we have alpha, beta, gamma, delta. Alpha plus beta plus gamma plus, sorry, gamma minus delta. How much is this? 8, 6, 18 minus 8. So this seems 24. That is option number 4. Any doubt you have in this? Please do let me know.
Sir,
Yes, please.
sir, can you explain me this one more from p power 8, sir?
See, like p power 8, we are multiplying p power 4 with p power 4. What is p power 4? That is 2i minus 3p. We are multiplying 2i minus 3p into 2i minus 3p. That is square of that. 2i minus 3p whole square is 4i square plus 9p square minus 12p into I. I square is I only, so 4i. P into I, that is p only, minus 12p plus 9p square. Substituting p square from here. So if I substitute p square from here, this is what I have. Simplify p power 8 is 39 minus 21p, which is similar to p to the power alpha. Now compare them, we get alpha is equals to 8, gamma plus delta is equals to, by 2 equals 13. Solve it, gamma plus delta is 26. In the same way, you subtract these two and then like you have p to the power beta here, right? In beta, I need minus 8p. Like I have seen initially in p square it is -1, and then like in p power 4 it is -3, in p power 8 it is -21. In between p power 4 and in between p power 8 it is there. It can be 5, it can be 6. Right? If 6 is not working, if I am getting greater than, I will do p power 4 into p. If 6 is less than, then I will do p power 6 into p. Clear? Understood? Now I did p power 6 and I got like here similar minus 8p here. So now using again comparing beta is 6, gamma minus delta by 2 is 5. Changing sides we get 10. And then like using these two equations, I got gamma value is 18, delta value is 8. Right? We need alpha, beta, gamma minus delta. I think 22 you should use characteristic polynomial. Try that once. Sorry, 27. Matrix is given. Now the relation is not given in 27. In 22, the characteristic polynomial relation is given. Trace of the matrix P is -2. Determinant of the matrix P is -1. So we get P square minus of minus plus 2P minus 1 is equals to 0. Try once. Can I scroll this one up? Can I scroll this one up? Solve that 27, dear Mithun. Any doubt you have in this? 27 to it. Where you are writing? What the answer? How much is the n value? 6, huh? That's it. Got the answer? Doing. Got the answer?
Sir, 6 is correct.
So like let us mark attendance. Anybody didn't punch downstairs? No ID card with you? You all punched, right? Then your name should be there. So like you guys do one thing. Meanwhile, I'm marking attendance. Go to the previous page. Go to the previous page, non-PYQs. Like it should be PYQ of advance, one part. Problem number 10, please. It was like in comprehension, one part is this one. It is easier one out of that 3. Remaining 2 are little trickier. So like I'm marking attendance. Meanwhile, you solve step 2 like the 10th problem. R is there offline? Who is Visahan here? Online is there. What first bench students doing? Watching final Australia versus South Africa. Right? First bench I said no, how you guys are saying. So then I think you would have seen the problem. Right? Step 2, problem number 10, it is like advanced PYQ. They have given that let A be the set of all 3 by 3 matrices which are symmetric with entries 0 or 1 if there are 5 ones and 4 zeros. So like using 5 ones and 4 zeros, right? We need to form a symmetric matrix. So like they are asking how many such symmetric matrices are possible. Clear? So like first of all, you should know in general, order 3 symmetric matrix will be in this form: A, B, C, B and C, D, E, E and F. So like here, if you observe carefully, this is B and this is B. What you are filling in first row, second column, same should be coming in second row, first column, right? So like first row, third column should be same as third row, first column, and then like these three will be coming in pairs. Clear? So like these two positions will be in pair, these two in pair, these two in pair. So like I need exactly 3 elements B, C, E. If I fill B, C, E, automatically same B, same C and same E will be filled here. And then like A, D, F can be same, can be different as well. Clear? Now like we need to say how many such symmetric matrices are there. Clear? So like what we are doing, like now I have 5 ones and then 4 zeros. Let us imagine a situation. I am taking like B is 1, C is 1, E is also 1, but like it won't be possible because 1 and 1, 2 I used, 1 and 1, 4 I used, 5 and then 6, 1 I need. Clear? Right? So that means all 3 cannot be ones. Clear? So like any 2 can be ones, right? 1 and 1 you can use like automatically 1 and 1. Clear? So like again, how many zeros are there? We have 4 zeros. If you have 4 zeros, all 3 cannot be 0. Clear? Any 2 can be 0. Like what I am doing, I am dividing the cases based on the diagonal elements. Depends on like first I'll arrange diagonal. Depends on this, I will after with remaining elements, I'll arrange non-diagonal elements. Clear? So like in case 1, let us assume a situation, right? There is no zero in principal diagonal. What does this mean? A, D, F cannot be 0. If it is not 0, then A, D, F, all 3 are equals to 1. Clear? So like now A is equals to, D is equals to, F is equals to 1. Clear? So like now, once I have 5 ones, I already used 3 in that. Now what do I have? I have 2 ones and then 4 zeros. Clear? Listen carefully. Now I am writing number of symmetric matrices is equals 1 into y is this one way of filling ADF with 1 1 1. Clear? So next I have 3 pairs. In this 3 pairs, one pair can be ones, remaining 2 pairs can be zeros. Understanding what I am speaking? Now like out of these 3 pairs, I am picking any one. It can be B pair or it can be C or it can be E. That pair I'll fill with ones, right? This one I can do in 3C one way. Out of these three, B, C, E, I picked one. So I filled one with that. Automatically, a remaining will be one here. Now, this remaining we should fill with zeros. Like the filling are like the number of ways of arranging that will be one and then one only. Understood this one? Like again, I am explaining. In one case, I assumed A, D, F is non-zero. There is no zero out of these three, right? So all three I fixed ones. Number of ways of filling three ones in three boxes is one way. Clear? So next what I did here is like out of this three pairs, one pair should be one, remaining pair should be zeros, right? One is the different one, no? So like I am selecting one between B, C and E, right? Let's say I got B. That one selection is 3C one way. After selecting one and then one here. Clear? Now they asked us to use 5 ones. We used 5 ones. 3 in the diagonal. Remaining 2 are in the piece. Clear? Now once we did use 5 ones, now zeros. Zeros is like 0 and 0, 0 and 0. 4 boxes, 4 zeros, one way. Clear? So that's what 1 into 3C 1 into 1. So like I have 3 such matrices like which contains no zero in the diagonal. Like I am asking, what do you think? Can I keep a single zero in the diagonal? Can I keep a single zero in the diagonal? Huh? Why no? If I keep single zero in the diagonal, right? Now the three zeros I need to fill in non-diagonal, that is not possible. Clear? So if single zero is not possible, then what about all three zeros? If I keep all three zeros in the diagonal, in that case also there is a zero left out. One zero cannot be filled in non-diagonal elements. Clear? So now the remaining cases, second case, in second case, 1 0 is not possible, then 3 zeros is also not possible. Then what we have? There is only 1 0 in diagonal. If there is only 1 0 in diagonal, like listen, I have three elements, right? In three elements, A can be 0 or D can be 0 or F can be 0. Like selecting one out of these three, that is 3C1, and there I will drop 0. Remaining two, I should drop once. Clear? So oh, yes. 1 0 is not possible. Sorry. 2 zeros. Sorry, 2 zeros. Like 2 zeros. I got confused into 2 zeros I need to fill. So 2 zeros I need to fill now out of 3. You select any two. That is 3C2. Once you select any two, there you drop zeros. Clear? So like maybe A is equals, D is equals 0 and F is equals 1. Right? Number of symmetric matrices is equals, right? First I am selecting 2 out of the 3 elements in a principal diagonal. Let's say A and D I selected. In A and D I dropped zeros, that I can do in one way. In F I should drop 1. Clear? So like into 1. So listen to me carefully. Now they have given us 5 ones, 4 zeros. Now how many we used? We used 2 zeros in this, right? Now remaining is 2 and then like remaining is 4 here. Clear? So like 6 is there, pairs is there, right? Out of like in these cases, B and B can be zeros, C and C can be zeros, E and E can be zeros. A remaining two will be occupied with ones. Clear? So like now we are selecting any one out of these three in between B and B, C and C, E and D. There you drop zeros, and then like remaining will be occupied with ones. There is like 3 into 3, 9 in this case. Total 12 symmetric matrices we have. Do you understand this one? Difficult sum? So like any doubts here? Then copy please. Sir, what is the 3C1 for? Second 3C1 for. See like in the diagonal, like you go here. In A, B, F, we kept 2 zeros. 4 are there, 2 zeros we used, another 2 is there. This 2 I can use in B and B, I can use in C and C, I can use in E and D. So like what I did, I wrote 3C1, out of 3 selecting any one, dropping zeros. 6. No, why? If you write 6C2, it can be B and E. Clear? Any other doubts? Copy, please. Total symmetric matrices in this is 12. Any doubt in this, anybody? So like, let me give some homework. Sums. Our next class will be on Tuesday only. So like, just tell me 18th one, did we solve in class? I think yes. Then 19th one, consider as homework. If you already solved, not for you. If you, then what about 20? We didn't solve in class, then you consider as homework. I think 21 we solved. 22 we solved, 23 we solved, 24 we solved. Try 25, 26. I think 27 you solved today only. What about 28? What about 28? Not yet. Then 28 you mark. 29, I think you cannot do as of now. If you are learning matrices now, you can do only if you know about inverse and adjoint of a matrix. So 29, I am not suggesting, you can do later once you finish the adjoint of a matrix. Then 31 and 33, I should teach one model. 30 and 33, sorry, 30 and 33. What about 31? We did in class. Then you mark that one as homework. How many total it came? 6. I think 6 will do. That will do. Remaining, I think like some models I should teach, and then like some problems we can do only after finishing determinants concepts. Like determinants, once we finish determinants again, we'll get back to this and we'll solve problems. One more class, I think we are done with matrices. What is remaining is like elementary operations on a matrix. Elementary operations and then how to find inverse. Now after doing them, we can see like maybe one class, remaining class, we can do the problems. Then we can start determinants from Tuesday and Thursday. We'll be having Thursday's class. Clear? So then I think that's it for the day. I would like to say thank you for attending my class. You can go home if you copied this. I already marked attendance.
Thank you, sir.
Toma.
Thank you, sir.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you, sir. Thank you, sir. Thank you, sir. Thank you, sir. What you guys are doing in last two benches? It's, that's only.